On a football team, the most overlooked position would be the kicker. The kicker is usually the one standing apart from the rest of the team with his fellow kickers. Now, when the game is on the line and the team only needs 3 points to seal the win, this is the time to shine. There is only one chance for the kicker to get the team to victory, and he must use physics to be successful. What many people don't realize is the importance of physics in kicking the football, and that kicking the football is a projectile motion. Before the ball is kicked, he must try to accomplish an important law of physics, Newton's second law. The kicker must apply the correct force, create the correct angle between the ball and the foot, and have the highest amount of acceleration that he can produce. If the kicker can produce enough force on the ball, accelerate their foot through the ball, and kick the ball at the correct angle, the kicker should be able to kick his team to victory. How do they kick it so far? This simple question is not easily answered. There are many factors that go into kicking a field goal. Two well-known factors are wind resistance and Earth's gravitational pull. However, the Newton's second law is an important aspect to know in kicking. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. This factor is not known as the other factors in kicking a field goal. This law is very important for a kicker. So let's break down Newton's second law. The mass of the football is relatively unchanging. The acceleration is dependent on the kicker. This force net of what the kicker is trying to overcome is what he sends the ball through the air with and through the field goal post. Now, a displacement versus time graph is a good illustration of a field goal's flight. The displacement time graph shows this flight. As the displacement goes up, the time increases, but as the displacement goes down, the time gets bigger as well. So as you can see in the graph, when t equals 0, displacement equals 0. I used m to stay consistent with the graph in meters. But as the ball takes flight and its displacement increases, so does t. However, when the ball reaches its maximum displacement of 20 meters on the graph, the ball begins to start returning back to m equals 0, but as the time increases on it as well. So the slope is also caused by Earth's gravitational force acting on the ball and air resistance as it brings it back to Earth. So let's move on to momentum. Momentum is what pushes the ball through the air. It's produced by the kicker. This transfer is what helps the ball overcome Earth's gravitational pull and the air-wind resistance. In this picture, you can see the kicker with a bent knee as he builds his momentum. The kicker also builds up momentum when he's running up to the ball. His arms spread are used for balance, and his pointed toe is prepping for a good follow-through. On the website, The World of Sports Science, there is a breakdown of angular momentum. It states the physics of kicking a field goal involves angular momentum. L equals I, or moment of inertia, I, in angular velocity, where I equals moment of inertia and W equals angular velocity. The moment of inertia equals mass times the length of the axis of rotation that passes through the kicker's hip joint, where leg mass is about 35 pounds for an average kicker. Ball mass is 0.91 pounds, and axis length is about 3 feet. For the collision, the equation for the conservation of angular momentum involves the momentum of the kicker's leg and ball before the collision equaling the momentum of the leg and ball after the collision. These formulas are important in finding the momentum and very important for the kicker to see how his momentum and follow-through transfer to the ball. Momentum continued. This physics movement is very important for the kicker. The momentum the kicker can produce successfully and transfer to the ball will allow the kicker to make the field goal. Let's also go back to how to do the physics of field goals. They state a larger momentum allows the kicker to apply a larger force on the ball. If you have a large momentum, the ball or projectile will be able to go to a further distance and reach a greater height. If you have a small momentum, the ball or projectile will not be able to go very far, and it will not reach a great height. Therefore, having a different amount of momentum affects the projectile motion of a football. Moving on to angles. Angles in the football. This is two different angles that are very important. The hash marks and the kicking angle that the kicker takes on the ball. The first angle comes before the ball is even snapped. This is in the hash marks and when the kicker sets the ball up. David Park, a professor at UGA, talks about these angles and actually came up with this representation. As you can see in the picture, the closer the field goal is, even at the same or at the angle of the side of the hash mark, the sharper the angle comes for the kicker to kick. So the closer the better, depending on the hash mark. So here David Park talks about angles of a field goal setup. The angle measurements at various distance clearly shows that the kicker has a wider range of angle to make a field goal when he is closer to the upright. This is within the allowance of a field goal range. We can conclude that the kicker has a better angle in terms of the width of angles from a closer distance. This is important because the better angle he speaks of is when the ball is located on the hash mark of a football field. Now, sometimes the hash marks change per the kicker because of their preference, but normally the conclusion is correct what Mr. Park had to say about the better angle in terms of the width of angles from a closer distance. Ball location on the field is important for the field, not only for distance but also where the ball is between the hash marks. Kicker must line the ball up correctly before the ball is even snapped. He and the holder must be on the same page on where the ball needs to be placed for the kick. The other angle for the kicker is how his foot meets the ball and the orientation of the football. Now, in this instance, the holder becomes an important factor. There's different preferences for kickers, and if they want to have the ball held up more upright or at a slight angle. One kicker, Alex Henry in the NFL, he prefers it straight up. In a popular mechanics article, Tim Newcomb interviewed biomechanics professor Jeff Hawks, who said tilting it, talking about the football, lowers the center of mass, making it tougher to strike the sweet spot. This upright position will hopefully allow the kicker to be successful, but also the team. So, concluding things, the kicker must produce the right amount of force to overcome the gravitational pull, wind resistance, air resistance, and have the right angle to whereas he does not kick it too high and not far, or where he doesn't kick the ball in the middle and produce a low-angled beeline style kick, or in other terms, a worm burner. So in conclusion, the kicker must use Newton's second law of motion to obtain the correct acceleration on the ball in order for it to travel through the field goal post. The kicker depends heavily on the holder and how he positions the ball, but also on how the kicker and the holder set the ball or set the location of where the ball is to be placed before the ball is even snapped. With the kicker aiming to having an arching flight path for the ball, he has to put enough force behind the ball to overcome the gravitational pull of the earth. When professional and college kickers make long-range kicks look easy, this is the best thing they can do. Because if they get out of balance and lose their form, let me show you here, go back to here, under momentum, how the kicker's arms are nice and straight to keep his balance. If they get out of balance and lose their form, they will not be able to maximize their acceleration, momentum, or force through the ball to make the field goal. And to show my works cited and images cited, that is that.